So welcome students. So in this question you're given that you have a hyperbola x square minus y square is equal to a square and y is equal to x square, a parabola. Now the question is, if a real circle passes through the point of intersections of these two curves, then what are your conclusions about the possible values of a and the size of the circle? So now how do we do this? So now you have a theoretical point which says that a curve, if you have two curves, s is equal to 0 and s dash is equal to 0. You have two curves, s is equal to 0 and s dash is equal to 0, then s plus lambda s dash is equal to 0 represents a curve which passes through the point of intersections of these two curves. So represents a curve passing through the point of intersections of s is equal to 0 and s dash is equal to 0. Now once we have this, now let us try to apply this concept to this problem. Now s is equal to 0, you have x square minus y square minus a square, this is the first curve, plus lambda times x square minus y is equal to 0. s1 plus lambda s2 is equal to 0. So this represents some curve which passes through the point of intersections of these two curves. Now I don't want any curve, I want a circle, because if a circle can pass through these points, obviously I want a circle equation which will be of this form. So if this equation has to represent a circle, so what should be the condition? So there is no xy term. So if a general equation has to represent a circle, the two conditions are xy term should not be there and the coefficient of x square and coefficient of y square should be same. So let us equate the x square coefficient and y square coefficient. So x square times 1 plus lambda minus y square minus a square minus lambda y is equal to 0. So 1 plus lambda should be equal to minus 1. So lambda should be equal to minus 2. So if lambda is equal to minus 2, then x square and y square coefficients will be same and this will represent a circle. So now substitute lambda is equal to minus 2. So you get the equation as minus x square minus y square minus a square plus 2y is equal to 0. So if you uniformly multiply everything with a minus sign, you get x square plus y square minus 2y plus a square is equal to 0. So this is a circle which passed through all the 4 points. So now you may feel that, okay, you're always getting a circle. So what's the meaning of this question? So the logic is, now this represents a real circle, because in this question you're given that you want a real circle. So for every value of a square, this will not be a real circle. So what's the concept of real circle, point circle and imaginary circle? So this circle will be real if g square plus f square minus c is greater than or equal to 0. So if a circle, what is the theory, x square plus y square plus 2gx plus 2fy plus c is equal to 0. If this has to represent a real circle, then g square plus f square minus c should be greater than or equal to 0. So greater than 0, it's a circle. Greater than 0, it's a circle with a finite radius. Equal to 0, it will be a point circle. So obviously I should remove this equality for this question because these are 4 different points. Obviously you cannot have a point circle passing through these 4 points. So you have to have a finite radius. So g square plus f square minus c is greater than 0. So if you apply that formula in this, so g is 0, f square is 1 minus c minus a square is greater than 0. That is, a square is less than 1. So a belongs to minus 1 comma plus 1. So a belongs to minus 1 comma plus 1. So that means if a belongs to minus 1 to plus 1, you have a circle passing through the points of intersections. But apart from this, there should be one more condition which should ensure some point of intersection between these two curves. So if a is very large, these two curves need not have a point of intersection. So first there should be point of intersection, then you have a circle in this case. So now when will these two curves will have a point of intersection? That means these two curves, if I solve them, you should get some finite answers. So if I solve these two curves, y is equal to x square. So x square minus x power 4 is equal to a square. So x power 4 minus x square plus a square is equal to 0. X power 4 minus x square plus a square is equal to 0. So this equation should have some real solutions. This equation should have some real solutions. So what is the condition which ensures that this equation will have a real solution? So let us try to solve this question. So the answers to this quadratic equation are x square is equal to, you can see that this is a quadratic in x square. X square is equal to 1 plus or minus root of b square minus 4ac, 1 minus 4a square by 2. So x square is 1 plus root of something by 2, which is a positive number. So x square is a positive number, x will have some positive real roots. So for whatever values of a, as long as this root is nicely defined, you'll have some solution for x. But when will x not have a real solution? If this becomes negative. If you have a negative number inside square root, you won't have any roots for x square. That means you won't have any root for x. That means these two curves will not intersect each other. So for these two curves to intersect each other, the condition is 1 minus 4a square should be greater than or equal to 0. They can be tangential also. So equal to 0. So 4a square is less than or equal to 1, a square less than or equal to 1 by 4. This implies a belong to minus 1 by 2 to 1 by 2. So a belongs to minus 1 by 2 to 1 by 2, closed minus 1 by 2 to 1 by 2. So if you have minus 1 by 2 and plus 1 by 2, exactly minus 1 by 2 and plus 1 by 2, x square will be, so this will become 0. So x square will be 1 by 2. It is x is equal to plus or minus 1 by root 2. That means this curve and the hyperbola will touch each other and go if a is equal to plus or minus 1 by 2. So anywhere in between plus or minus 1 by 2, these two curves will intersect at 4 points. When a is equal to 0, this curve will become a pair of lines. This will not be a hyperbola anymore. So a not equal to 0, because in the question it's given that this is a hyperbola. So a not equal to 0 and a belongs to minus 1 by 2 to 1 by 2, so that they intersect, and a belongs to minus 1 to 1 if a circle has to pass through these 4 points of intersection. If a real circle has to pass through the points of intersection. So what is the common interval? The common interval is a belongs to minus 1 by 2 to 1 by 2 minus 0. Now once we have specified this limit for a, now you have 4 points of intersection, and this condition is also valid. So a circle passes through these 4 points. Now what is the area of the circle? So to get the area of the circle, we need the radius. So we have already derived the circle. X square plus y square minus 2y plus a square is equal to 0. This is what we have derived earlier. So what is the radius of the circle, or r square? R square is equal to g square plus f square minus c. That is 1 minus a square. So what is the area of this circle? So area is nothing but pi r square, that is pi minus pi a square. Pi minus pi a square. So this is valid as long as you have a fixed circle passing through these points. So as long as you have 4 points, this is a circle, and you have the area as pi minus pi a square. But as you can see, in the case of exactly 1 by 2 and minus 1 by 2, you have only 2 points of intersections. So from these 2 points of intersections, you can draw the circle, but apart from this, you can draw many more circles. Apart from this circle, you can draw many more circles. So you cannot specify the area in that case. So in the case of exactly minus 1 by 2 and plus 1 by 2, you cannot specify the area, because if you have 4 different points, you can have only one circle which passes through them. But if you have only 2 points, you can have infinitely many circles passing through those 2 points. Hence, area is equal to pi minus pi a square is valid only in the open minus 1 by 2 to 1 by 2 except 0. So option C is also right. Thank you.